Hello and welcome to a video that's introducing system of equations word problems. We started systems of equations and solving them in Unit 4 last semester with sections 4.1 and 4.2. So now today we have an introduction to section 4.3. We're going to start by talking about coins and their monetary value. So imagine that you have a collection of coins, but the kind of coins that you have are going to be a little bit different. We're going to use a lot of decimals, but we're also going to use a calculator a lot. So notice how I have Desmos up here. The first question here says that you have a collection of 35 coins. So imagine you just have a pile of 35 coins. However, of those 35 coins, there's only nickels and quarters. You could have any combination of nickels and quarters as long as those two numbers add up to 35. So now this is where you start to think about your monetary value. You know that each nickel is worth 5 cents. If you've forgotten how to write that as money, 0.05. There's a decimal. If the question here then on part C is asking us about 7 nickels, well, you know 1 nickel is worth 5 cents, 2 nickels are worth 10 cents. You can multiply. 7 nickels would be multiplying 7 by 0.05. It's really important here that you do use the the periods, and all of the zeros in the right spots. Place value is important here. So 7 nickels are worth 35 cents. In your collection, though it's not just nickels, you also have quarters. So the next question you're asking yourself is, how much is a quarter worth? Each quarter is worth 25 cents. So as a decimal, 0.25. That means that you know 1 quarter is worth 25 cents, 2 quarters are worth 50 cents, and then if I want to know the value of 7 quarters, I just take the value of 1 quarter and multiply it by 7. So using a calculator is really important here. $1.75 would be the value of 7 quarters. The reason that this is helpful is because now you have an idea going forward of how you're going to find the total of each of these coin combinations. You're going to find the number of nickels and multiply that by how much a nickel is worth, and then the number of quarters and multiply that by how much a quarter is worth. In the first row here, we're told that there are 17 nickels. We know that there are 35 total coins, but first, if I know there are 17 nickels, I can multiply 17 by the value of a nickel, and that tells me that those 17 nickels are worth 85 cents. This is helpful because I need to add the monetary value of both the nickels and the quarters together, so it's easiest to just start with the monetary value of the coin that I was given. I know that my collection is going to have 35 coins in it. If I know 17 of those were nickels, then if I do 35 minus 17, I have 18. That means that in this collection of 35 coins, there are 17 nickels and 18 quarters. I know that each quarter is worth 25 cents, so the monetary value of 18 quarters is $4.50. There are 2 totals here. The first total is the 35 coins, but the second total is the monetary value. So I know that I'm always going to have a total of 35 coins, but here, if I want this particular combination's value, I have to add 85 cents and $4.50 together mean that this specific combination of coins has a monetary value of $5.35. Now you have 3 more combinations to go through before we're going to try to look at what an equation for this might look like. In the second row, you're given the quarter first. So in the last problem, we were told there were 17 nickels in our collection. This time, there are 4 quarters in our collection. So you have to determine what's the monetary value of 4 quarters. Well, 4 times 25, 0.25, that gives me $1. Now, if my collection has 35 coins in it, and I know that 4 of them are quarters, if I subtract those 4 quarters out from the collection of 35 coins total, then I know that there are 31 nickels in this particular collection. I also know the individual value of each nickel is 5 cents. So the monetary value of 31 nickels is $1.55. If I want to find the total monetary value of this combination, I need to add those two numbers together. $1.55 added to $1 is going to give me a monetary value of $2.55. At this point, it's interesting to look at how both of those coin collections are 35 coins each, but they're worth different amounts of money. Let's go ahead and finish this table before we try to write an equation. In the third row, what we're told is that our collection of 35 coins features 26 nickels. I know that 26 nickels are worth $1.30. So that's the first part. I'm still looking at a collection of 35 coins. So if I started out with 35 coins and I know that 26 of them are nickels, then I'm going to subtract. That means that there are only 9 coins left, and those 9 coins have to be quarters. I know that each quarter has a worth of 25 cents, so 9 quarters have a monetary value of $2.25. This allows me to complete the third row of this table, comparing all of our different sets of coin combinations, even though they're always 35 coins. The total monetary value in this row is $1.30 added to $2.25, and when we put those together, we end up with a grand total of $3.55. Also interesting to see the 55 cents and how we can get there in a lot of different ways. And now we're at our last row of the first problem. This time we're told about quarters first instead of the nickels being the information we're given first. So if I know that I have 11 quarters in my collection, first I'm going to figure out that those quarters are each worth $2.75 as a part of my collection. Now, that means that if I know that 35 coins is how many I have total, 11 of them were quarters. So I can start with my 35 coins, take out the 11 quarters, and that means there are 24 coins left, and there are only nickels and quarters in my collection. So there are 24 nickels. I know that each nickel is worth 5 cents, so when I multiply, I end up with $1.20 as the monetary value of 24 nickels. Next, I want to find the actual monetary value, so I add the nickels and the quarters together, $1.20, then I add $2.75 for a grand total of $3.95. And now you can kind of look at your table and ask yourself really what we did algebraically, because the equation is usually the hardest part. So first we had to think about how many nickels there were, but also how much a nickel was worth. Then we're adding because we wanted a total. So your operation is going to be addition after you multiply your nickels. Then you had to do the same for the quarters. We multiplied not only the number of quarters, but how much a quarter was worth each time. And that's how I ended up with a total. I'm not going to use a y or anything like that here because I'm going to use a y for my quarters, but just a little bit more standard form. You might say that you have 0.05 times x, or the monetary value of a set of nickels, added to 0.25 y, or the monetary value of a set of quarters. And that's how you would end up with your total, which you could use as a $sign or a t. If you wanted to use variables that were different than x and y, you could do that as well. But at this point, we've gone through our first problem. This is really a system of equations, even if you didn't recognize it, and hopefully it seems manageable, because it is.